behind time. Now we're good. So Tim Moreton, CTO, co-founder or founder of Acunu, great analytics on top of Cassandra. Probably nobody that knows more about BI and Cassandra more, because what, you got a PhD, right? I give him a hard time because he brings it up a lot. But Tim has really been great about, every time I hear his talk, I always get inspired to do more stuff with Cassandra, which is probably not a good idea because I'm kind of hooked on it. But anyway, Tim Moreton, Acunu.
Thank you, Patrick. So yeah, I'm going to talk to you today about one of the major use cases that we see people deploy Cassandra for, which is real-time analytics. So being able to get insight in a relatively timely fashion, either in terms of the time from a piece of data arriving to being able to do something with that, or just in terms of sort of low latency results as well. So analytics is the topic of the discussion. And in fact, it was actually at Cassandra EU, the previous Cassandra EU, which ran, I think, about 18 months ago. I think it was April the year before last, that we first announced the beta of Acunu Analytics, which is our product to enable this sort of real-time BI that runs over Cassandra and is powered by Cassandra. And I'm sort of going to tell you a little bit about what we've learned about real-time use cases, the best way of using Cassandra for this sort of purpose. So I guess the first question that we often hear is really, when should you be deploying a NoSQL solution, and when should you be looking towards a Hadoop solution for solving analytical problems? You know, you have some big data workload in some dimensions, either velocity, variety, or volume, and the first question that people often ask is, well, you know, what is the sort of set of tools that I should be using to try and tackle those problems? We like to categorize these things into two broad sets of use cases. So I talk about, over on the left here, discovery analytics. So this is the sort of bung all of your data into a big repository, into a sort of data lake, if you like, and then come back and ask questions of it later. So this is where Hadoop is a really great fit. So it's the use of this sort of unstructured data warehouse where your BI guys, or perhaps they're called data scientists now because you need them to be able to program, come at a large set of data, perhaps put together disparate sources and types of data, and look for, I guess, mainly unknown unknowns, you know, the sort of so-called needles in a haystack, to try and inform business processes that perhaps, you know, need to change months down the line. So, you know, how should I change my supply chain based on the analysis of marketing results and meteorological data? That sort of use case. It's where the data is sort of supposed to sing to you. I'm not really that much of a believer in data necessarily singing to you. We at Acunu focus a lot more on what I would describe as operational intelligence. So that is where you have some idea in advance about the sort of metrics that matter to your business or to your operations, your systems, and where 5 minutes matters. So where there's a sort of better business decision you could make on the back of having access to timely information, or where there's corrective action that you can take if something's going wrong, if you could predict it, either just in time or potentially proactively using predictive analytics, and spot something ahead of time going wonky so that you can fix that. So that's really the area that we're really interested in. And I think that you can characterize these things in two ways, really. You know, over on the left, you've got complex, long-running analytics, a total lack of structure. On the right, you know, the structure of the data is typically well known. You're talking about click streams, Internet of Things, you know, telemetry data from telcos, financial market data. And by the way, those are all applications that Acunu Analytics has been deployed against since we launched the beta 18 months ago. And across a wide range of verticals. And there, you know, you don't need a Hadoop cluster if you're in advertising to tell you that click-through rate is an important metric for your business. If you're doing infrastructure and operations stuff, you know that the latency of API calls is something that you should be watching. And if you're doing manufacturing and you're doing production line analytics, you know that the the pass-fail rate is obviously something that you should have a good handle on. You don't need a Hadoop cluster to tell you that. So when you have some insight into the metrics of matter, this is where I think Cassandra comes into its own as a platform. And we love Cassandra at Acunu. We organised the last Cassandra EU, and we've been working closely with DataStax on this one. We've been working with Cassandra and contributing to it for a number of years now. And I think some of the key things that we like about it are common to all use cases for Cassandra, but in particular resonate around analytics. So Cassandra is very scalable. It has no single point of failure, either in terms of actual availability or in terms of performance either. So degradation and performance in one node can often be worked around pretty easily. It's very fast, and in particular it's very fast for writes, and that's great for real-time analytical workloads. If you think about what's happening there, you have this big stream of data coming at you. It's typically immutable, so the fact that Cassandra doesn't really have very strong transactional semantics can be sort of like set to one side. It doesn't really matter. That's a good design trade-off for this particular application. And very often we see a rate of writes of about 1,000 to 1 writes to reads. So people are often collecting this huge stream of data, not often updating the various elements or events that are coming in, and trying to summarize or analyze the sort of the output of that stream. So in a basic sense, they're counting it. That's the sort of fundamental building block there of analytics. And Cassandra, of course, has great counter support. That was a feature that was originally contributed by Twitter for one of the for basically an analytical application, real-time analytics application that they were building on top of Cassandra. So Cassandra's a great fit for those reasons, and what's become really clear to us in the last 12 months as we've been working with Cassandra customers is that it is really arrived in terms of being deployed for mission-critical use cases in mainstream, what I would characterize as probably traditionally quite risk-averse organizations. And that's very interesting. Cassandra is really here right now for those use cases. So some of you may be familiar with this cartoon. NoSQL giveth and NoSQL taketh away. And one of the things that you do encounter when you move to a NoSQL platform is quite often if you're coming from a relational background, you lose the ability to you lose the sort of the availability of a very rich query framework. So this is a great cartoon which sort of has been around since the early days of NoSQL, and of course it's poking fun at our friends over at React and Bashe. But the point still really does stand for Cassandra. And by the way, I've not ever seen a Cassandra or a React developer in a suit, but there you go. So the point still stands with Cassandra as well, right? So a key value interface, regardless of the sort of additions and great enhancements that CQL3 has added on top of it, is still quite a difficult thing to work with. Getting your head around denormalization, around the idea that you have to plan in advance for how you're going to be reading the data out before you put it in, and making sure that you structure your entire database in that fashion is a difficult thing to do. It's especially difficult when your boss comes to you, as many of you will have experienced, a few weeks later, just after, or perhaps the afternoon that you're showing them your Cassandra application, and says, that's great, but actually the requirements have changed, or it would be really nice if your application could do this. And that agility is something that is really, really hard to maintain when you're crafting these data models manually, especially with denormalization thrown into the mix. So there are still barriers there to use Cassandra just on its own for building these analytical applications. So this is what we originally built Acunu Analytics to tackle. We said, okay, so the database, Cassandra is a superb database, but the notion of what is a database perhaps has gone a layer down. So rather than talking about a system where we can ask rich queries of it, a database is something that manages your data in terms of getting you great performance, great availability, and durability across data centers, and the query layer, I guess, is something that you want to build on top of it. So we built Acunu Analytics to work with Cassandra's best characteristics, I guess, to sort of keep the spirit of denormalization, but to bring you back the ability to ask complex questions of data and to do so in real time. So I'm going to talk very quickly about some of the technology that underpins this. So Acunu Analytics is basically a system which takes in events. We have a range of different APIs for doing that. We have a HTTP API, Flume integration, MQ integration. We've just added Kafka integration as well. So you can just throw data at Acunu in JSON format. And by the way, one of the things that used to be a bit of a pain with Cassandra was getting data in. It's less of an issue now, but it's still nice to be able to connect many different data sources easily. And so Acunu really, you can think of, from a Cassandra point of view at least, as a sort of automatic data modeling tool for Cassandra. So we sit Cassandra, we are powered by Cassandra, we sit Cassandra underneath us, and we use Cassandra to store raw events and the intermediate results that we use to enable real-time analytics. And you can think of this really as mapping incoming events into updates and writes into Cassandra, into a data model that you build by telling us about the metrics that you want real-time insight into, and then mapping queries into reads on those intermediate results and raw events. And that is, I guess, half of what we've done. We have this analytics engine, but we also have a bunch of built-in visualization tools. So we have a browser-based UI for building rich visualizations, widgets, and dashboards, and being able to see those change and update in real time, and a framework for raising alerts out the other side as well. So it's really sort of, for analytical applications, it's really about adding functionality on top of the great foundations that Cassandra already provides. I'm going to tell you a little bit about how it works. So the first thing, the way that we allow you to express the metrics that matter to you and the way that we can give you instant answers without having to trawl across billions of raw events is to ask you to define, I guess, what are analogous to OLAP-style aggregate cubes. So a cube is a definition of an aggregate, so a top K or count or standard deviation or something like that, and a set of dimensions. So I want to be able to take this click stream and I want to be able to see the unique number of visitors, and I want to be able to break that down by browser and geography and by customer segment, for example. And so armed with that information, we can then allow you to collect events. And those events will potentially result in multiple updates into Cassandra. So we maintain these aggregate cubes essentially as materialized views in Cassandra using, by basically building our own data model in Cassandra. And the way that it's sort of cheating in a sense, because if you struggle building and optimizing, in particular optimizing data models in Cassandra, Acunu Analytics just sort of does that for you by you describing a cube in very SQL-like language. We also store the raw events, and you'll see why in a sec. But the premise is really then that you can build these rich SQL-like queries in our imaginatively titled Acunu query language that runs over this. And what you have access to there is many of the sort of concepts that are familiar to you from a SQL world. So select, where, group by, limit, having, join, and all of those sorts of keywords. But we decompose those queries onto slices of the aggregate data. So you never have to go back to the raw events to be able to answer queries that you've prepared for in advance by setting up these cubes. We also maintain a mapping to the raw events so that you can drill down to see the underlying result, or I guess the sort of original raw data that contributed to a particular aggregate. So if you're looking at a distribution of latencies and you want to see what this particular spike is at a particular time, or for a particular API call, I don't know, you can go through and click through and see that. And the point about agility is interesting as well, because once you've made one of these cubes, you're invariably going to want to change it. And we allow you to do that, and we sort of have this mechanism called Backfill for taking the schema that you've set up, looking at what you're trying to do to change it, and then basically backfilling by rolling over the existing events to give you historical context on that newly defined cube. And obviously that's a process which does need to touch the raw events and does need to get parallelized across all the nodes in the cluster. But it means that when your boss asks you, actually, it would be really nice if you could visualize these results or get me an answer to this other question which you didn't know about previously. It's much, much easier to do that. You don't need to write any coding. You don't need to do any gluing. You don't need to be changing your Cassandra data model to do that. It's just a click of a button in a UI. And so really what we're doing here is providing some tools that if you're a developer, you make your life easier for building analytical applications. So we simplify the ingest process, we give you rich queries, we make denormalization not a process which is going to hurt your agility, and we give you a bunch of built-in visualizations, which I'll talk a little bit about later. So that's great, but so it's all really for a developer. And so if you look at the workflow around how you actually set these things up in our current version, or until yesterday our current version of Acunu Analytics, there's a lot of the developer in there, right? So you've got to install Cassandra and you've got to install Acunu Analytics. That's certainly not something that I would leave to a CEO. Even yet, even though it's getting easier. You've got to create tables. You then have to define your cubes, because we can't answer queries in real time until you've set up those cubes. And then you've got to turn on data feed, and then your business guy can build those widgets. That's great. But then the whole process of setting up new cubes to refine that is the business guy is basically going to have to go and pester the developer or the technical guy again to be able to allow that. So that all changes from our perspective today. And what we're doing with Acunu Analytics V5, which we're announcing today, and which you'll be able to download, I think, this afternoon from our website, is to make this process something that really empowers the business user. So I sort of like to describe it as the tableauization of streaming data. I don't know whether that's a message that resonates with you, but I love Tableau. It makes it really, really easy to get value out of CSV files and databases that are, you have access to on your machine. It empowers people who can use pivot tables in Excel, right? That's an incredibly powerful tool. But for streaming data and big data, that tooling has just not been there so far. And I think that's something that we're really, really looking to tackle and that we're really excited about. So, of course, you're still going to need your dev to install it. But we've done a number of things that mean the business user can get stuck in to doing real-time analytics on Cassandra. And the first one is to basically automatically infer the structure of tables and these dimensions that you need to set up in Acunu from a sample event file. So in the same way that in Excel, you go into the import wizard and you see a sort of set of data and a table, and it guesses what the formats of that data is, and then you just click import, and 90% of the time it gets it right, and occasionally you have to change some stuff. We do exactly the same thing. So you just upload a file of a set of JSON objects or a set of CSV events, and we're like, okay, so you're collecting clickstream data, and these are the fields, and these are the ways that you'd like to set that up. And then we'll pull those events in. And the next step is we've added a drag and drop explore view, so you can basically build queries in the UI just by saying, I want this on this axis, I want this on this axis, and then show me that graph. And the point about this is that previously you had this slightly awkward dependency because you needed the cubes to be able to ask the queries. What we've done now is enable ad hoc queries, which use a sample of the data that's already available in the system to give you sort of a rough sketch of what the results are going to look like. And when you click Add to Dashboard, we automatically infer the cubes that you're going to need to get real-time answers there, and we build those cubes, we populate them with historic data if you want, and then you get real-time results. So turning on the data feed to actually keep this process happening in real time is something that we still need a developer for. But we're working on that in a sense, because we've added a mechanism for plugging in new connectors through a very simple public API. We push that API to GitHub, and we've provided some examples. So our new Kafka integration is just one of those examples. So it's very easy now for you to get the business guy, as developers, to get the business guy out of your hair, even at this stage, by just giving them access to an ingester for the particular data source that you need. And finally, the final step, once you've got that data feed out of the way, is that you can come back and refine these widgets, go back into the Explore view, change your queries, and if there's a cube there to support it, you'll get real-time answers that are complete. And if you've got ad hoc, if you haven't, then we'll give you ad hoc sample results, and we'll allow you to build those new things into widgets and use and get historical data and historical context into those cubes automatically. So you're sort of enabling this sort of process of experimenting and refining, which is invariably something that is just key to all sort of analytics. So just to demonstrate how easy this is, we have our own business guy. So who could screw this up worse in your company than the VP of marketing? No offense, Di, but no. So what I'd like to do is invite our VP marketing, Di Clegg, onto the stage, just to demonstrate on a live instance that even the marketing guy can do real-time big data analytics on a Cassandra platform from very little scratch. And just to give you an indication of how long Di has had to play with this demo, he was going to start experimenting with it about 11:45 last night, but we forgot to give him access to it. So so at 7:45 this morning, Di had a quick play just to check that he sort of knew where things were. So hopefully this real-time experiment will give you some insight into just how easy it is. So I mean, to go back to the cartoon, Di, could you come on the stage and build some dashboards?
I think I'll do it. Tim, did you just tell me to go build my own dashboard?
I believe I did, Di.
Well, I'll just give it a go, shall I?
Let me find you a browser window. That will help. I'm not sure dealing with multiple windows is within the domain of...
A bit challenging for
It's a bit
marketing.
challenging for me, for sure. Here we go. There we go. In fact, excuse a slight technical delay while I mirror the screens, so that Di can actually see what he's doing without craning his neck all the time. There we go. Right, experiment.
Ooh, we're going to these. Okay, so first thing I want to do is I want to play with some tweets, because I'm going to build a Twitter analytics application. So I've got a file which has got some of the some sample tweets in that already, and I'm going to kind of load that up. There's all my sample tweets. We see those? Yep, good.
Oh, there's Jerometron. He's here.
Yep. Sorry? You've got a different mouse setup than I have.
Oh, sorry. You can scroll the old way.
Oh, my goodness me. Old version. Ooh, ooh. Yeah. So here it's parsed the table, so it's looking at what it is. It thinks keywords are a pass, they're not. They're a bag. A series of strings, and then it thinks tweets a path. That's a string. So I've got an inferred structure, but I get the opportunity to kind of play with that and modify it. I've also got automatically ticked for me is, do you want me to insert the events from that file? Obviously, it's kind of parsing those out. So I'll create my table, uploaded those. It says, okay, what do you want to do with them? Well, like all good tweet analytics apps, we'll start with count, shall we? And we'll group it by, let me see, let's group it by the keywords. Well, in fact, sorry, before I do that, you can see I've got 40. It infers. It says, well, you asked me to count, so it just says, well, I'll give you a metric and it counts them. There's 40 of them in this file. So now I group them by keyword. And by default, it can't show a group by on a metric, so it works out well. Pie chart, any good to you? I could, let me just, so I can see it better, I'm going to limit it to 50, the top 15 of that, but I could also go off-piste. I don't have to use the visualizations that it wants to use. I can maybe show that as a bar, and that's cool, and I've got my tweets by the different keywords, but then maybe, actually, I've gone off that. I'm exploring my data. I've said, oh, that's interesting, but it's not grabbing me too much. Why don't I summarize it by the country of origin of that, group it by country. And it shows me, but that's, you know, country by origin. It's country, that's geographic. Let's stick it on a map. Yeah, and then, in fact, it's color coding the map for me. If I look at my widget properties, yeah, it's actually color coding those by lowest to highest values of those by default automatically if I use a map. But I can adjust those, of course, I want to. And then next thing I can do is, you're looking very nervous, Tim.
No, I was just going to say, well, it's just when you go off-piste on the live demo, that's the...
yeah, you worry about that one later when I get there, yeah? Yeah, so it's inferred that if I want to put this on a dashboard, that implies I want it real time. Now, I was only on 40, so therefore it was instant anyway, just doing queries on 40. But when I get on the live feed, I want it cubed up. So it says, well, if you want that to work as a real-time query, this is the cube I have to create for you. Remember, Tim talked about how you had to have the tech guy would work out the data model for you and create you the appropriate cubes. I don't have to do that. The software's done that for me. Yeah, do that. And also I can say, yes, create that, and then populate the cube with the historic data so that it will, I've got those 40 tweets and they're in my, in the event store, just in the pool, and I'm creating a new cube. It says, okay, backfill the history into my cube for me, and add a widget, and there's no data returned because it's all in the past. Yep. And there's my data. And that's it. Like, well, that's cool. But the only problem is I've only done this on like a test file. Now I know what I want to do. I've explored my data. Now let's go back to explore. And now I'm going to go on the live. And this is when Tim's going to get really nervous on a live tweet feed. So if I just do this, like count all tweets ever, would that work? Yeah? You don't think so? So now I do a count.
So you see you have this slider here between speed and precision, which is basically how many events at most will use to produce a sort of sample result.
So it's counted to 2,000, and I've got it here on the speed and the precision is about in the middle. Let's move it down to that. Yeah. So that's if I put it to the high speed. I'm now sampling the live Twitter feed, but at very high speed. I have very low sample set in order to keep this up to it while I'm going. And now if I group that by country, again, it thinks, oh, that'll fit on a thing. I don't like that. Let's put it on the map. There is relatively, now because I'm getting relatively little data, and because I've got the high sample on that, but I can add that to the dashboard. Add it to the same dashboard. That's the test data. That's the live data. And I think I built my own dashboard, Tim.
I believe you did, Di. Of course, I start on the wrong slide. So that's really all I wanted to cover, just to give you a quick overview of the key things that are coming up in Acunu Analytics v5. We have a couple of things you can do. If you want to download it, it'll be available this afternoon from acunu.com/download. And if you want a exclusive limited edition Acunu t-shirt with that very message on, come to the Acunu booth very quickly. Dai's going to model it here for you. There we go, lovely. It's another black computer science t-shirt you pick up from a conference. I'm sure you haven't got one of those yet. Thank you. Any questions? Hey.
Hey, so what kind of data volumes could we push into this? I mean, what do you, and how, if we run stuff down, how much hardware would we need?
So we have, I think the highest volume we've run it at on a cluster of about 8 nodes in a New York investment bank was peaked at 250,000 events a second. 400,000 events a second, which equates to about 40 billion events a day. Can somebody check my maths? Does that answer your question?
Yeah.
So, I mean, typically we see, we see typical setups where we have a sort of right behind buffer in analytics to sort of absorb counter increments. So basically we build a number of column families behind the scenes. We map these sort of high level group bys and wheres and cubes that you're building onto those column families. And every event will increment a set of counters. And so we absorb the +1s in analytics. You can choose to basically absorb them in a sort of right behind buffer, which is also a cache. And we limit the load on your Cassandra cluster by like throwing +35s into Cassandra rather than +1. So that helps a lot. But yeah, I mean, you can do an awful lot on very small clusters actually. Yes?
So 400,000 events per second, that's cool, but how many cubes are behind that? Because that's what kills you.
Right. So so there is obviously a trade-off in terms of the amount of aggregation you do ahead of time. So we have, in fact, it's just a factor, right? So the more events, the fewer cubes. But I mean, typically we see setups that run very, very nicely where the cubes that you set up contribute to, say, 100 counter increments for every event that comes in. And that they work absolutely fine, especially if there's locality in your data and you're using the buffer. So the other point is that in the Acunu query language, we support basically post-processing steps as well. So ways of doing aggregation on the results of cube data, which are sort of equivalent to taking a cube and piping it into something else, and taking 2 cube results and doing like the max of something minus the min of something else, or ungrouping or grouping by an additional element. And that's a way of, it's a flexible way of allowing you to sort of reduce the cubes that you set up in advance.
So I know in previous versions of analytics there was an API that you can get the data out of. Is that still there? So if we want to build our own dashboards on top of Bradley's dashboards?
Yeah, absolutely. So for example, I can do something like, I haven't even looked at what table I'm on here. Okay, let's do something quick. Count by user. That might blow the thing up. But I can click on the AQL tab, and I think it did blow it up. When you've got a successful demo, never go back to it. Okay, hang on. Let me.
Do you want an expert back on stage?
Yes, please, Di. I've gone to the wrong instance. Okay, let me just answer that verbally. Yes, so there is so the dashboards use a HTTP API where you can write AQL to, and that HTTP API is available, of course, to any application you want to build on top of it, and the same API is used by the dashboards, and yeah, we see very often people writing both applications and dashboards through these charts. And in fact, if I do this and show you one of these things, I can actually take one of these dashboards and embed it as well. So we have a JavaScript library which allows you to embed this directly into your own site. And because it's backed by Cassandra, which has pretty low, great high availability characteristics, low latency reads, and we do a lot of the work ahead of time, it's very easy to embed these widgets in your own site. And we have store procedures and various security mechanisms coming up as well, which make that a safe thing to do. To give your end users, your partners, your advertisers, your customers, access to these analytics. So it's not just a tool that you have to keep for yourselves. Hi.
Hello. For joint queries, do you do the joint in memory or do you pre-compute them in Cassandra in the column family?
Good question. So how do we do joins? So the joins in AQL are designed to be low cardinality joins that you do across. So there's no silver bullet here, right? So if you need to do joins across high cardinality dimensions, data warehouses have been optimizing those sorts of techniques for many, many years. And the whole idea about Acunu really is to try and do as little work after the fact as possible. So we support a form of ingest time join where as an event comes in, you can enrich that event with other information. So for example, if you're collecting tweets and they didn't have lat long associated with them, you could basically do a lookup on lat long from somewhere, and without affecting your throughput too much, we could then enrich that event and then basically use those additional fields in the cubes as you go.
So is there something which prevents me from doing bad joins? Don't need lots of comments.
So very bad joins are prevented. Quite bad joins are not currently prevented. The ability of you to shoot yourself in the foot is diminishing with every release. But that's the big data space. Hi.
How much does it cost?
You should come and chat afterwards. All I'll say is that we have customers that are bootstrap startups, and we have customers that are among the world's largest enterprises. So we love working with everyone.
As far as I understand, you need to have your pre-set up Cassandra cluster and then install this.
Yeah.
How does this software affect the existing Cassandra cluster?
Good question. So we work in our own key space on a Cassandra cluster. So you just say in the configuration what key space you want us to create, or create it yourself, and we'll operate in that. Some folk use us on an existing cluster. Some folk create their own cluster. We also have an AMI image which comes with Cassandra in it as well, which avoids the hassle of setting it up separately. Not that it's very hard these days. Question at the...
What about data duplication? Do you duplicate any data across from your cluster to the way you have to do your analytics?
Do we duplicate data? So I guess we duplicate a little bit of data, I guess, because the same event will feature in different points in your analytic results, if you like. But that is, because what we do is mostly quantitative analytics, that's just counts, typically. And we keep a single instance of the raw event. And Cassandra's built-in compression is actually very, very good. We really don't see space ever being a real issue in production clusters. We have a way of purging events. So, if you've got time bucket set up, for example, we can say keep events at a per second granularity for the last day, keep events at a per minute granularity for the last week, and so on. So we can purge events like that.
How is the replay implemented when you're going to history and doing the graphs over there?
Good question. So we implement a distributed work queue. So we diff the schemas, we diff the schemas, we work out exactly what bits of what column families we need to update. We push that work onto a queue which is polled by every node in the analytics cluster. So analytics runs as a scale-out tier above Cassandra, or typically on the same boxes. It's a common deployment pattern, and each of those will do a particular slice of time, and then those jobs will be pushed back in. So I guess it's a bit like a map producer. Sam up there wrote it, so he can tell you the gory details afterwards if you're interested. Do you want to wave, Sam? There we go. Okay, I think we've got time for probably one more question. No? Okay, great. Well, thanks very much for your time, everyone.
All right, everyone, we're on a break.